Hi friends, welcome to the channel. Today in this video we'll be solving some of the previous year questions that has appeared for various entrance exams from solid state chemistry. So the first question is from TIFR 2016 question paper, and the question says that in a face-centered arrangement of A and B atoms, A atoms are at the corners of a unit cell and B atoms are at the face centers. For each unit cell, one A atom is missing from a corner and one B atom is missing from one face position. They're asking for the simplest formula of the resultant compound. So we have two types of atoms here. They have told that there are two types of atoms, atom A and atom B. It is told that A atoms are at the corners of a unit cell. So we know that generally there are 8 corners and 8 corners are filled by atoms generally. And each of the atom would give rise to a contribution of 1 by 8 to that particular unit cell. That is what we studied. But here it is told that one of the corner atom is missing. One of the A atoms is missing from a corner, which means that instead of 8 corners being filled, now in this case only 7 corners are being filled. So A atoms, we have 7 atoms and each of the atom would give rise to a contribution of 1 by 8. Now coming to the B side, B atoms, it is told that the B atoms are at the face centers, and we know that a unit cell has 6 faces. So since it has 6 faces, all the 6 faces would be generally occupied and each face would give rise to a contribution of 1 by 2 to a particular unit cell. But in this case, it is told that one of the phase position atom B is missing. From one of the phase position, the B atom is missing. So instead of 6 phases, now we have only 5 phases having B atoms, and so it is 5 phases and each phase atom would give rise to a contribution of 1 by 2. So B atom would give rise to 5 by 2 contribution and A atom would give rise to 7 by 8 contribution. Now since this is in fractions, we have to clear these fractions, and to clear these fractions, both sides are multiplying with 8. If I multiply with 8, this side would become 7 and this side would become 5 into 8 by 2, that is 5 into 4, that is 20. So therefore, I can write the formula of this compound, or my resultant compound would have a formula A7B20. It's a very simple question, direct question. We just have to know the contribution, how much each side or each corner atom or face shared atom makes to that particular unit cell. Clear? Let's move on to the next question. So this is from GATE 2013. The question says that a metal crystallizes in FCC cubic lattice and the lattice parameter is given to be 4.20. Lattice parameter means we know that it is A. The edge length is given to be 4.20 Armstrong and they're asking for the shortest atom to atom contact distance in the lattice. They want the shortest atom to atom contact distance. So now if we consider one side of an FCC, so this is how it would look like. We have atoms touching each other, and what they are asking for in this is from here, this point to the center of this point. This is the atom to atom contact distance that they're asking for. This would be equal to R, this half of it, this much distance till here, it would be R, and then again from there to here, it's another R. So that's R plus R, that's the diameter that they're asking for, D. Half of that atom and half of this atom, R plus R, that is 2R, which is D diameter, that is what they're asking for. And how can we find that? So let us just, this is the thing that they want, let us just consider the whole of it till the end. Let us join and let me mark these points as A, B and C, and this point can be marked as O, and we know that since it's a unit cell of lattice parameter is given to be 4.20, so this AB is A, that is 4.20, and BC is also taken as A. Its value is given to be 4.20. They are the sides length of the sides of the unit cell. Now I consider the triangle. In triangle, I consider the triangle ABC. I apply the Pythagoras theorem. When I apply the Pythagoras theorem, I can find that the hypotenuse square, which is AC square, equal to AB square plus BC square. Now that will be equal to A square plus A square, that is equal to 2A square. But in our case, I want AC, means AC would be equal to root 2A. Now I don't want the whole AC, I have to find the distance AO. AO is half of AC, so I have to find AO. that is equal to half half of AC by 2. So that is root 2 A by 2, which is equal to A by root 2, and my A value is given to be 4.20. So when I do 4.20 by root 2, my value comes out to be 2.97 Armstrong approximately upon calculation. So option B is the right answer for this question. It is 2.97 Armstrong. Clear? In the third question, they've told that AgI crystallizes in a zinc blende structure with I- ions at the lattice points. And what is the fraction of tetrahedral voids occupied by Ag plus ions? The percentage, this is what they have asked. The Ag plus ion, how much does it occupy? What fraction of the tetrahedral voids are occupied by Ag plus ions if AgI has a structure similar to that of zinc blende? Now, this was a Delhi University entrance exam question from 2019 paper. Now, for this zinc blende structure, what is the zinc blende structure? Just let us have a look at this table. So, this is a general table for different types of structures, like we have sodium chloride, zinc sulfide, fluoride structure, antifluoride, and cesium chloride. Different structures are there. And we know that in zinc sulfide, if you look, you can find that in case of zinc sulfide, if you're looking here, you can find that my cations, Ag plus, which is the cation that is given in the question, or in this case, it would be Zn2 plus. It would occupy alternate tetrahedral voids. It does not occupy all the tetrahedral voids. It occupies only alternate tetrahedral voids. Okay, let's come back to our question. So in this question, suppose if we have Ni minus ions are there, means there would be Nag plus ions also we would have, because it is AgI. Ni minus ions means Nag plus ions would also be there, and this Ag plus ions are occupying only half of the tetrahedral voids. Alternate tetrahedral voids means half of the tetrahedral voids. So generally what we know that is, if there are n spheres or n atoms for a unit cell, there would be n octahedral voids, then there would be n octahedral voids, and totally there would be 2n tetrahedral voids. This is what the formula says. If we have n atoms, we would have n octahedral voids and 2n tetrahedral voids. But in this case, only half of the tetrahedral voids is filled. So generally we have 2n. So 2n tetrahedral voids is 100%, but for us only n tetrahedral voids, half of it. Alternate ones means half of it is only being filled. So it is n tetrahedral voids which is being filled. Therefore, that means it would be 100 by 2. That is only 50% is being filled by Ag plus ions. Clear? Let's move to the next question. So this is a GATE 2016 question, and the question says that when the crystals of NaCl are heated in presence of sodium vapors, they turn yellow. This is due to the formation of which of the following defect? Whether it's due to a Schottky defect, Frenkel defect, F center or H center is the question. And when we study about the defects, we study non-stoichiometric part, and we study about the anionic vacancy part, that like sodium chloride, when it is heated in presence of the vapors of sodium, what is being formed? An electron is being formed. An electron is present at one of the positions. One of the anion would be missing and an electron would be present there, and this electron is responsible for getting excited to the higher level, and when it returns back to the lower level, it emits radiations of various colors, and that's how we see those different colors. And those electrons that are present are called F centers. So F centers are responsible for this yellow color that is shown when crystals of sodium chloride are heated in presence of sodium vapors. So option C is the right answer here. In the next question, what they have told is the density of lithium metal is given to be 0.53 gram per centimeter cube, and the separation of 100 planes of the metal is 350 picometer. Determine the structure of the lattice given the molar mass of lithium to be 6.94 gram per mole. They've given the molar mass of lithium, they've given the density, they've given a Miller indices for a plane, and they have given the separation of planes, that is interplanar distance is also given. So we have to determine the structure. And how can we determine the structure? We can determine using this density formula. So let us write the density formula first. Since density is given, so we know that the density is Z, that is the number of atoms into molar mass divided by A cube into Avogadro number Na. This is the formula that we have. Now, if, rho is given, density is given, molar mass is given, Na is a constant which we know, and A means edge length that we can calculate from D value. D value and Miller indices, interplanar distance and Miller indices, there's a relation that connects them from which we can obtain the A value. And if you know that if from these values, if we can calculate the Z value, then I can say whether depending on what Z value I'm getting, I can say if it's an FCC or a BCC, SCC or a diamond structure. Now, first step is I have to find the A value. A value is not given, so I have to find the A value. And we know that D equal to A by root of H square plus K square plus L square. This is the formula we have. The interplanar distance D is given to be 350 picometer. That is equal to A by root of H is given as 1. So 1 square plus 0 square plus 0 square. HKL is 100. So that is how. So this denominator would become 1. So A becomes equal to 350 picometer, or that is equal to 350 into 10 raised to minus 12 meter. This is what I have. And the density is in centimeter cube. So that also I have to convert it to meter. So this density also, so this would become 0.53 divided by that centimeter cube means centimeter to meter is 10 raised to minus 2. The whole cube is there centimeter cube because it's volume. Density is mass by volume. Volume is A cube, meter cube or centimeter cube here we have. So I convert that also to meter. Then I just have to substitute all these values here and I have to find the value of Z. So I substitute this to be 0.53, 0.53 into 10 raised to minus 6. I bring it up. So this becomes 10 raised to 6. That becomes equal to Z into the molar mass is given to be 6.94. And I divided by A cube. A came out to be 350 into 10 raised to minus 12 meter. I have the whole cube of that. I take the cube of that into Avogadro number, that is 6.022 into 10 raised to 23 is the value that I have. When I do the calculation, I take everything to the other side, and when I do the calculation, my Z value comes out to be approximately 2. I get 1.95 something, which is approximately 2. And if my Z value is 2, it would correspond to a body center cube. For a simple cubic crystal lattice, the Z value is 1. Z means the number of atoms per unit cell. Z value is 1. For BCC it is 2. For FCC it is 4. So that we have already seen. So for BCC it is 2. So my answer should be a BCC crystal lattice. Here. The next question is from GATE 2003. So the question says that the crystal system which has the highest and the lowest symmetries. So how symmetrical is my system? The one which is having the highest symmetrical and the one which is the lowest symmetrical in the crystal systems. So these are the different crystal systems that we have. We have already studied them. So out of these crystal systems, if you look at the tables, the one which has all angles and sides equal would be the most symmetrical one. And so the first one that I have here, the cubic which I have here, all sides are equal, all angles are equal. And for every other things, either a side would be different or an angle would be different. Some difference would be there. Only for cubical, all my sides are equal, all my angles are also equal to 90. It is a perfect symmetrical shape. So cubic crystal system is the most symmetrical. And when I come down, the least symmetrical means nothing should be equal. Angles are all different, sides are all different. So if I look, when I come down, it is the triclinic one, which is having all sides different and all angles different. So the most symmetrical is cubic and the least symmetrical is triclinic. So my option A, B is found to be the right one. Option B is right. Moving on to the next question. It is from NET exam, June 2014 paper. So here they've asked, X-ray diffraction does not give any structural information for which of the following. So they've given different options and they've asked for which of it does the X-ray diffraction do not produce any pattern. X-ray diffraction is not obtained. And it is the amorphous solids which does not give X-ray diffraction patterns, clear patterns. when we have crystalline, when we take the diffraction X-ray after getting, we get proper peaks for crystalline solids. But because they have regular three-dimensional arrangement, and for X-ray diffraction to occur, we should have planes. And different, we can get proper planes only in case of crystalline solids with regular three-dimensional arrangement. But when you come to amorphous solids, they do not have a regular three-dimensional pattern. Their pattern is irregular, so they do not have any plane that would cause the proper diffraction. And for amorphous solids, the peaks wouldn't be sharp. We get broad peaks like this. We wouldn't be able to identify any particular property, structural information from that. So it's amorphous solids which do not give X-ray diffraction. So the next question is from IIT JAM 2016 paper. So here it is told that when a diffraction experiment is conducted with X-rays of wavelength 1.54 Armstrong, a diffraction line is obtained corresponding to 2 theta equal to 20.8 degree, and they've asked for the interplanar distance in Armstrong. So we just have to use the Bragg's equation here. So what is the Bragg's equation? That we know that Bragg's equation says that n lambda is equal to 2d sine theta, and the d value is the what we have to find. And since n is not given, means by default we take the order to be first order. So n is taken to be 1. So it is 1 into lambda is 1.54, that is equal to 2 into d is the one that we have to find, sine 2 theta is given to be 20.8, so theta would be equal to 10.4. So when I substitute the values and I take everything to the other side and I calculate, my d value comes out to be 4.27 Armstrong. This would be the value for this particular question. And in the next question, they asked for the value, they've given the value of D11 plane in a cubic crystal to be 325.6 picometer, and they've asked for the value of D33 plane. That is what they have asked for the value. So now here what we have to know is, so in this question, so we can do it in two ways. There is a long method and there's a short method that can be done. And in the long method, let me tell you the long method first, which is the actual by equation method. So here if you see that we know that D is given by equal to A by root of h square plus k square plus L square. This is, we know that. So in the first case, D11 means, so that is given by 325.6 picometer would be equal to A by root of 1 square plus 1 square plus 1 square, that is root 3. So A would be 325.6 into root 3. Now this A I can substitute. This is in case of D11. Now to find the value for D33. So D33 I don't know. So D33 can be taken as, it can be taken as, instead of this A, I can substitute it as 325.6 root 3. The previous value that I got divided by root of h square plus k square plus L square. That is 3 square plus 3 square plus 3 square. That's 9 plus 9 plus 9. So 27. So I can do it in this way and I can calculate the value will come out to be 108.5 picometer. This is how I can get D33 from the first D11 value. I can find out the value of A and then substitute that A value for finding the D33 value. But simply without doing all these calculations, you can, in such cases, you can do that when if D11 is given to be 325.6 means D333 value would be half by 3. We just have to do this. Whatever D11 value we have, 3 times it is the next one's plane. It is 3 times. So I just have to divide the D11's value by 3. If I had, I would get the same answer. Suppose if I had D222 means, if this was asked means, I just have to divide my D111 value by 2. D222 means I divided by 2. D333 plane means I divided by 3. So how many times extra this plane is? So that many times I can just divide that number and I would get the answer correctly. I don't have to find this A1 and go. So this is a NET December 2012 question. So here they've asked for the angle between the planes that are represented by the Miller indices 110 and 111 in a simple cubic lattice. They need the angle, the theta value. If theta is the angle between the two planes, and if two planes are there, H1 K1 L1 is one plane and H2 K2 L2 is another plane, means the angle theta is the angle between the two planes. Then there's a formula which says that, the formula says that cos theta is given by H1 H2 plus K1 K2 plus L1 L2 divided by root of H1 square plus K1 square plus L1 square into again square root of next plane H2 square plus K2 square plus L2 square. This is the equation that we have. So I just have to substitute the values of 110 and 111 in place of H1, H2 and K1, K2 and L1, L2. So upon substitution, I can find that my cos theta becomes equal to H1 is 1, H2 is also 1, 1 into 1 plus again K1 is 1, K2 is 1 plus 0 into 1 divided by square root of 1 square plus 1 square plus 0 square into square root of 1 square plus 1 square plus 1 square. This is what I get. This comes out to be 2 by root 2 into root 3, that is equal to root of 2 by 3. Root 2 by 3 is cos theta, and so theta is not 30, 45 or 60. When I take cos inverse, theta is cos inverse root 2 by 3. That is not equal to 30 degree, 45 degree or 60 degree. Cos 30 would be root 3 by 2, not root 2 by 3. Cos 45 is also 1 by root 2 and cos 60 would be 1 by 2. So it's not any of these. The option is none of these is the right answer, which is option D. None of these would be the right answer for this question. So this is the last question for this video, and this is from University of Hyderabad Entrance Examination 2015 paper. So here what they've told is, they've told that they want the Miller index for a phase having intercepts 1 by 2a, 2b and infinity c, where a, b and c are the unit cell axis. They've given the intercepts and they're asking for the Miller indices. Now we know how to calculate the Miller indices. There are 3 steps. So the first step is writing the intercepts itself. So let's write down the intercepts. That's our first step. So instead of XYZ axis, if we are taken the ABC axis, so this is taken to be half and this is given to be 2 and this is given to be infinity. And the second step is writing the reciprocal. So let us write the reciprocal of this intercept. 1 by 2 would become 2, 2 would become 1 by 2 and 1 by infinity gets the reciprocal 0. And the last step is clearing the fractions. We have to clear the fraction part and get simple whole numbers. And for that, I can simply multiply everything by 2 so that the fraction gets cleared. So the 2 into 2 would become 4. 1 by 2 into 2 would become 1 and 0 into 2, that's 0. So my Miller index would be 410. So that is option A that I have here would be the right answer for this question. So that's it for today. Thank you so much.